Namaste. I welcome one and all for this special talk by our guest, Archana Raghuram. It's my pleasure to introduce her. Archana Raghuram is YouTuber, former CEO, United Way, Chennai, former Senior Director, Cognizant. Archana Raghuram runs a YouTube channel called Temples, Books and Science, where she shares her knowledge on Hindu philosophy, the arts, architecture, and legends of our ancient temples and books that are at the intersection of science and spirituality. Recently, she has added a video in connection with the Prize for Physics 2022. That is, scientists who proved that universe is not really. And she has given the parallels to Advaita Vedanta that has garnered more than 2.5 lakh views. Archana has worn many hats. She was the global head of Cognizant's volunteering program, which grew to become the world's largest corporate volunteering program under her leadership. She won national and international recognition for this achievement. She was awarded the prestigious Forbes India Philanthropy Award in the Good Samaritan category by the Forbes India magazine. She was honored as one of the 100 most creative people in business by a leading US publication, Fast Company. The Brew magazine recognized her as an outstanding women achiever in her chosen field. After her stint in Cognizant, she headed as international non-profit organization called United Way Chennai as its executive director and CEO. And I feel this is very important. After nearly 25 years in corporate world, she started her YouTube channel to share her knowledge on subjects she's passionate about. She also writes articles on philosophy and life skills. She is a frequent contributor to the Life Positive magazine. And Archana ji, I'm really attracted to your talks on YouTube. And I was wondering what is the source of all these things in Archana ji. That I found out. As a child, she used to watch the science magazine Cosmos by Carl Sagan. And it's inspired her a permanent love for physics. And whenever I was interacting with Archana ji, she used to say Hari Om. So I was presuming that she must be the student of Chinmayananda. But now she told me she is an ardent devotee as well as the disciple of Swami Paramarthananda. So what a great combination coming to be part of our Jnana Sudha series. I welcome you from the bottom of my heart. And her motivating TED Talk on the art of volunteering has 23.7 million subscribers. So how lucky we are all to be with you, Archana, spending your time with us. We welcome you.
Thank you so much, Alakaji. It's my pleasure and my honor to be here speaking at this forum, which is associated with Sringeri Mutt. I feel really it's the blessing of my guru that I'm here. Thank you so much for that lovely introduction. So let me get started on the talk. So today I plan to talk on the subject of God, science and God. Alakaji and her husband saw my video on this subject and they wanted me to talk about this subject. So I have done several videos on this subject in my YouTube channel. So I have condensed it for the purpose of this talk. Okay. There was this French scientist called Pierre Laplace. He was a very big scientist. Those of you who have done engineering will know that we have learned his theorem in mathematics and all. So one day he presented his findings to Napoleon, who was then the emperor of France. Napoleon, after listening to him, asked him, where does God fit into your equations, into your theories? Where is the role of God? And Laplace apparently replied, I have no need for that hypothesis. But today, if he were asked the same question, it'll be very difficult for him to give this answer. Because more and more, as we understand the basic laws of nature, as our understanding of physics is improving, we are finding that more and more we can feel the presence of an intelligence and purpose behind the creation, behind our universe. And now with advances in quantum physics, consciousness has come to the forefront in physics. It seems to play a central role in working of physics. So today I want to talk about this intersection of science and our ancient philosophy, how hundreds of years of scientific research has now led us back to the wisdom of our rishis. So I want to give you some examples for both these points. What is the proof of intelligence behind the creation, behind our creation, how science is uncovering this, and also how quantum physics is uncannily similar to Vedanta, Advaita Vedanta. Okay, one of the things which is baffling scientists is why the universe seems so fine-tuned for life. It's generally a few decades ago, it was thought this whole universe was a random occurrence and life also happened by chance. But more and more as we discover things in physics, we are finding that that assumption is wrong. The universe seems to be so fine-tuned for life. Even if small things vary in the universe, stars, planets, and life would not exist. Let me give you some examples. Let us begin with Big Bang. This is the event that set the universe into motion. The universe began with a Big Bang. And generally, when we think of Big Bang, we think of this huge explosion which started off the process of creation. And when we think of an explosion, we think of it as a chaotic event, like a bomb bursting, like a nuclear bomb exploding, an uncontrolled and chaotic event. But there are so many things peculiar about the Big Bang. One of the things that is really peculiar about it is if its strength varied even by 0.0001%, then the universe would not exist. There would be no stars, there'd be no planets, and we won't be here. It is less of an explosion and more of a perfectly tuned event, which was so perfectly balanced. Even a little change in it would have resulted in our universe not being there. Such a perfect value it has to create the stars, the moon, the galaxies, and us and life. So that is I'll tell you later why this is so baffling scientists so much. And next, what about all the forces that were created immediately after Big Bang? For those of you who can't see the slides, I will be talking through it. So that's not a problem. Don't worry about it. So there were 4 basic forces that were created immediately after Big Bang. This is the strong nuclear force, electromagnetism, weak nuclear force, and gravity. These forces are the building blocks of the universe. If you think of the universe as a building, these forces are the foundation and the framework around which the whole universe stands. And there is something very strange about these forces also. If you take the strong, weak nuclear forces and electromagnetic force, and if you vary them by 2%, plus or minus 2%, then the universe would not exist. And if you vary them by 0.5%, then life will not exist. And if you take gravity, which was created along with these forces, it is so much weaker than these first 3 forces. It is a trillion times weaker than the other 3 forces. And there is no explanation on why gravity, which was created with all the other forces, has to be so weak. But there is a purpose for gravity being so weak. It is because gravity is so weak, atom exists. If gravity was almost on par with the other three forces, the electrons, protons, and neutrons won't be in this form. They will crash into each other, and there will be an explosion. The atoms cannot exist if gravity was in the same range as the other three forces. It is as if somebody has dialed down gravity so that atom can exist. So this is another strange thing about these four fundamental forces. And like this, there are 45 constants in physics, like the mass of electron, gravitational constant, speed of light, and all of them have specific values that even if you change them by a small quantity, like 2%, 1%, 0.5%, the universe would not exist at all. Any of these constants are varied by a very small value, the universe would not exist. And why is this strange? Because random events don't look like this in real life. So far, science has assumed that the universe was created as a random event. Suddenly, out of nowhere, randomly universe arose. That was the assumption scientists had made about universe. But way all these values are presenting to us, it is clear that a random event could not have produced them. It is like almost a certainty that it could not have happened randomly. Let me tell you why. Now, let's say you pick up a heap of sand from the beach. You know, sand is a random set of particles lying on the beach. You pick up a heap of sand. Now you tell me, if you want to, like, how perfectly do the sand particles have to be organized for it to look like a heap? You can just drop that particles down and again pick it up and it will look exactly the same. However much how many ever different ways you organize the sand particles, the heap of sand will not change its appearance. So a random event will typically look like that. There'll be a large number of values it can assume and still look the same. That's typically how statistically a random event would look. But compare this with something which is designed, like a rocket, where it is designed for a specific purpose, and more sophisticated it is, more component parts it has, and even small changes will prevent it from crash, will cause it to crash. Like you would design a rocket, so many different components have to work together. A little software bug, one particular parameter, you make a mistake, then the entire thing will crash. It will not work. And how our universe is looking is like a rocket and not like the heap of sand. The way the parameters of our universe are organized, the way the parameters of our universe are presenting itself, it looks like a well-designed, perfectly tuned equipment for life to happen. Even a small change in it will prevent would have resulted in universe and life not happening at all. So this is kind of confusing many scientists. What is the explanation? They're trying to come up with an explanation without God being in the picture. That is why we have theories like there are multiple universes, millions of universes, and ours is just one of them. So out of million, we are in that one where life is possible. So that's an explanation which is being given. But if you look at the simplest possible explanation, that there is this one universe and it has occurred, it seems to have been perfectly designed for us to come into existence. That is why now physicists are coming up with this theory. There is a principle that is being put forward by many physicists, which is seriously being considered, that universe exists for the explicit purpose of creating life. There is a purpose to the universe. It's not a random occurrence. And it has been created for the explicit purpose for life to happen. It's called the anthropic principle. And there are several different versions of this principle, but net, this is what it states. There is a purpose to the universe, and that is to create life. And now when you look at this statement, can you see how closely it aligns to what the theory of karma says? What does law of karma says? Why is the universe created? The universe is created for all living beings to exhaust their karma. So a universe without a living being cannot exist. It's useless. The purpose of the universe is to ensure all living beings can exhaust their karmas and in the process accumulate more karma. So this anthropic principle seems to be converging to what law of karma is saying. Then next, let's go to another interesting concept in physics called entropy. It is described as the real dance of Shiva by a Western physicist, Carlo Rovioli. So entropy, those of you who are not familiar with this concept, entropy can be roughly translated as the disorderliness of a system. What does it measure? How disorder a system is. That's what entropy measures. So it's a very intuitive thing. What physics says, the second law of thermodynamics states, is that all systems move towards a state of higher entropy. So in other words, everything moved towards the state of higher disorderliness, higher state of messiness. And those of us who have children don't need any explanation for this law because we see it often in action. You just clean up your room, set it up and go, and you don't look at it for 2-3 days and it's in a total mess. So far we were blaming our children for this, but it's actually the law of physics which states that the entropy keeps on increasing. It is not if you don't control it as a natural course of thing, the messiness and disorderliness of a system keeps on increasing. So let us go to a more physics definition of entropy. Entropy actually means the number of ways you can organize a component part of something so that it looks the same. How many different ways you can arrange something so that it looks exactly the same. So let's go back to our sand example. We have this example of sand. You have a heap of sand in your hand. So how many different ways does the sand particle can be arranged so that it looks exactly like one heap of sand? You think about it for a second. You have a heap of sand in your hand. How many different ways can you arrange these sand particles so that it looks like a heap of sand? There's absolutely no order to the heap of sand. You can just shuffle it around and still it will look the same. You can drop the whole thing and pick it up again. It will look exactly the same. One heap of sand cannot be differentiated from another heap of sand. So a heap of sand is said to be in a state of high entropy, high disorderliness. Now compare this with a sand castle. How many different ways you can arrange the particles of sand so that it looks like a sand castle? So the number of different combinations is much less in a sand castle, right? So a sand castle is a low entropy arrangement, and a heap of sand which you pick up in your hand is a high entropy arrangement of the sand particles. This is clear? So let me give you another example of low and high entropy systems. Let's say you have a pack of cards. A pack of cards, 52 cards. Now you shuffle the deck of cards. So you have a particular arrangement of a shuffled deck of cards. It's a random arrangement, right? So how many random arrangements can you have of a deck of cards? That is, how many possible configurations of a shuffled deck of cards you can have? Can you take a guess? It's a really, really large number. It's 52 factorial. Nearly 8 into 10 to the power of 67 combinations of a shuffled deck of cards you can have. So a randomly shuffled deck of cards as a high entropy arrangement. So different ways you can shuffle and you cannot distinguish one arrangement from another. So a shuffled deck of card is a high entropy arrangement and it is very, very common. That is, it is 60, the number of arrangements which will look identical is a 68-digit number. And look at your right-hand side. Here you have an arranged set of cards, starting from ace of clubs, ending with king of spade. You arrange it sequentially. So how many different arrangements can you have of this sequential arrangement? You can have only one arrangement. Even if you take out one card and move it elsewhere, you will be able to make out the difference. So a sequentially arranged deck of cards is a very low entropy arrangement, and a shuffled deck of cards is a very high entropy arrangement. And you can understand why a shuffled deck of cards is more easily occurring in nature. Whereas when you find a sequentially arranged deck of cards, you will have to assume that somebody arranged it. You will never assume that somebody shuffled it and the shuffling resulted in this sequential arrangement, right? Just take a minute to absorb it. So when somebody shuffles a deck of cards and they open it, you will never expect it to be in a sequential arrangement like this, starting from ace of clubs, 2, 3, 4, 5, then diamond, then heart, then spade. That will never occur in a shuffled arrange. When you just shuffle a card, you have to take the effort to arrange it in this order. Correct? Why I'm emphasizing this point is when you come to the beginning of our universe, how the universe started, and you see what is the entropy of the universe when it started, it's a very low entropy. It's like that arranged set of cards. Just like this arranged set of cards is so unlikely to happen randomly, the low entropy beginning of the universe is that unlikely. It is impossible to imagine how unlikely it is that our universe should begin with such a low entropy. To give you an idea of how unlikely it is, let us go back to our deck of cards. So is it possible that when you shuffle a deck, you will get a perfectly sequenced arrangement? What is the probability of that? Let's look at what's the probability of that happening. Now, this is an analogy that I read, a beautiful analogy, which gives you the really impossible probability of that low entropy arrangement. Now, if you have 10 billion people in every planet, let's assume there are 10 billion people in every planet, 1 billion planets in every solar system, 500 billion galaxies in the universe, and 200 billion solar systems in every galaxy. And every single person, imagine the population, you can't even imagine the number. And every single person in this universe has been shuffling decks of cards at the rate of 1 million shuffles per second. Even then, that perfectly arranged sequence would not have occurred. The possibility of that is all possible arrangement of shuffled cards would not have occurred. So that is how rare this low entropy arrangement is. So it is possible. There's another example that is given to show how unlikely this is. Like, can you imagine human beings forming out of thin air randomly as a random event? A full-fledged human being forms himself out of thin air. What is the probability of that? That is higher than the probability that the universe should begin with such a low entropy by chance. So, and another interesting thing about entropy is time itself is born in entropy. Time itself is born in entropy. No other laws of physics or gravity or electromagnetism or even Einstein's law incorporates time. That is, past, present, and future does not exist in that equation. So it looks the same, whichever part, like time does not come, is not part of the theory at all. So only place where time appears is in entropy. Because the entropy of the universe keeps on increasing, we get the arrow of time. We move from past to present to the future, and it's not possible to move back because going to a state of low entropy is very, very difficult. Just like if you can break an egg, but you can't reform it back to a fully formed egg, right? That is the same reason why we can only move to the future and not go back to the past. So Kala, Shiva, the concept of time is born in entropy. And that is why in this book, I read this book last year called The Order of Time by a famous physicist called Carlo Rovelli. And there he describes this entropy as the dance of Shiva, the dance of ever-increasing entropy, nourished by the low entropy of the universe, is the real dance of Shiva, he says. The Nataraja, the dancing Shiva, Nataraja. And when I read this, I really felt like you can almost visualize Shiva starting off his dance of creation as Ananda Tandava and the whole universe vibrating to the rhythm of his drum. That's what, when you read about entropy, you can really visualize that. That is the beauty of entropy. Then So all these things, there are many other things, but I'm just giving you a few examples in physics, which seems to imply that there is an intention and an intelligence behind the creation. Unless you want to assume that there are infinite number of universes, if this is one universe and this is the only universe we are living in, then there is very little chance that all this could have happened randomly by a mere stroke of luck, that our universe would have been created this way. It's impossible. You cannot give any logical reasoning for the universe to be the way it is. All these parameters being designed the way it is. There has to be an intelligence and intention behind creation. Okay, and next we will move to quantum physics. See, or in case of classical physics, looking at the laws of nature, you can infer the presence of an intelligence of a creator. You can infer the presence of the creator. That is anumanam. But when you come to quantum physics, you can see it firsthand, pratyaksham. You know, when my guru was in one of his classes, he was telling about the various sources, various pramanams, various sources of knowledge. And the first is pratyaksham. You see it yourself. Second is anumanam. You infer. That is, you see smoke and you infer there has to be fire, right? So there is a big list of pramanams from which you can get knowledge. And the first two are pratyaksham and anumanam. So when you look at classical physics, you can infer that there has to be an intelligence behind the creation. But when you look at quantum physics, when you understand quantum physics, you can see consciousness in action. Consciousness is central to the functioning of quantum physics and central to the understanding of quantum physics. And I know this subject is hard. Both quantum physics and Advaita Vedanta are difficult subjects, but I think it really is worth making an effort to understand how both of them converge, because it's a matter of pride. Hundreds of years of scientific research has led back to the wisdom of our sages. Thousands of years back, without the benefit of all these telescopes and modern equipments, they have arrived at a truth which only now science is discovering. And it's really a matter of pride for all of us. So although the next few slides are going to be a little heavy, I hope you will stay with me. You'll stay with me and follow this. So first, let me tell you briefly about what Vedanta tells about consciousness. Consciousness, according to Vedanta, consciousness is not an emergent property of life. So generally in science, how is consciousness defined? Life happened, and as a consequence of life, consciousness emerged. So it's an emergent property of life. That's how science thinks of consciousness. But that's not how Vedanta thinks of consciousness. According to Vedanta, consciousness is the fundamental principle from which the whole universe emerged. Universe is created in consciousness, it is sustained by consciousness, and it will resolve into consciousness. And another important point of consciousness, which is particularly relevant for understanding quantum physics, is this. This consciousness is only a witness. It's a Shakshi Chaitanya. Generally, when we say something is a creator, this consciousness is a creator, we tend to imagine like this consciousness planned the universe, designed it, and created it. That's how we create it, right? But in case of Brahman, the consciousness principle, it is only the witness. The very act of witnessing creates the universe. So that is why this Brahman is called Sakshi Chaitanya. So because this is such a difficult concept to understand, in Vedanta, there is a famous analogy to explain the relationship between Brahman and the universe, the consciousness principle and universe. So they give the analogy of dream. So when you're sleeping and you're dreaming, what happens? The whole dream world is a product of your consciousness. So in your dream, you have a lot of inanimate objects also. You have mountains and rivers and stones. All the things in your dream are not conscious entities, but the entire dream world which you have projected is a product of your consciousness. Similarly, The whole universe is product of Brahman, the consciousness principle, but it is made up of both conscious and inanimate things, just like how it happens in your dream. And secondly, how do you create your dream? You just sleep and witness your dream. That's all your job is. You don't plan it, decide what are going to be the various articles in your dream. The deluding power of your sleep projects the dream and creates the dream. So that is what you are. You are just the sakshi, the witness of your dream. So this analogy is very frequently used in Vedanta to explain the relationship between Brahman and the universe. And it is this analogy which is represented in this form of Vishnu, Ranganatha, the sleeping Vishnu. So Vishnu in Yoga Nidra dreaming up the universe. So that is directly taken from the dream analogy of Vedanta. So with this in mind, let us go to quantum physics. So one of the fundamental things we need to understand in quantum physics is this experiment called double slit experiment. So if you want to know what is strange and quirky and weird about quantum physics, all you need to know is look at this experiment. This experiment is basically set up like this. So there is an electron gun which shoots electrons. In the center, there is a screen with two slits. So it's a screen which is closed everywhere except for these two openings, which you see here. And then you have a screen which will detect the electrons at the other side. Whenever the electron passes through the slits and hit the screen, it will make a mark on that screen on the other side. I hope everybody is able to see this slide. So what happens? What would you expect? You are shooting a set of electrons onto a screen which has two slits. So what would happen? What would you see? You will see that some of the electrons will bounce off the screen. Most of the electrons will bounce off the screens, but some of them will pass through those two slits and hit the screen at the opposite end, hit the detector at the opposite or at the other side. So only certain number of electrons which pass through the slits will emerge on the other side and hit the screen. So what would be the shape of the mark which these electrons leave on the screen? So you would expect two straight lines, parallel to the two slits. So since the electrons are passing only through those two slits and going straight and hitting the screen, the mark on the screen should be two straight lines parallel to the two slits. Okay, just take a minute to absorb this. This is how you would expect the mark to be. So you're sending a set of particles. These particles are passing through the slit and hitting the screen opposite to the slit in one straight line. So there will be only a straight line. Two straight lines should be there parallel to the slits. That's how the screen should look, right? But what they found when they shot these electrons was not two straight lines. They saw a series of dark and light lines across the width of the entire screen. It was not two straight lines as they expected, but a series of dark and light lines across the length of the screen. And this pattern was very strange because this kind of pattern will occur only when two waves collide, not when particles come and hit the screen. So let me explain how this happens. Let's say you have a clear pond of water, a still pond of water, and you're dropping a pebble in that pond. What would happen? What would you see? You will see a series of concentric circles emerging from the center of the pond, the point where the pebble fell. So this is actually a wave which is traveling through the surface of the water. Now, what happens if you put two pebbles? You're putting two pebbles close to each other in this still pond of water. So what will happen is you will have two sets of concentric circles around each of the pebble. So there'll be two waves traveling through the surface of the water, and they will collide with each other and form a pattern. If you can see the screen, you can see two waves colliding with each other and forming a pattern. And this pattern is called the interference pattern, which occurs when two waves collide. So, and this was the pattern which the scientists were able to see on the screen when they did the double slit experiment. So just to reiterate what happens. So you're shooting a particle from point A, but what is emerging is not a particle. It is like that waves which you see in the puddle. The concentric circles are emerging from that particle. And when it hits the screen in the middle, it is able to, this wave passes through those two slits and emerges as two waves. And then it hits the screen, it forms the pattern, and this pattern appears on the screen. So every single electron, even if you send one electron at a time into this experiment, each electron will behave like this. It will emerge as two waves and it will create a pattern on the screen. So this really confused the scientists. They wanted to know what was happening. So what they did is they put a detector near the double slits. Detectors, nothing like it's something like a camera. So what this detector will do is every time an electron passes through a slit, it will record it. It will record which slit the electron is passing through. Okay, so they put this detector and they wanted to see what happens, how the electrons are becoming waves. But what they found is as soon as they put the detector, the electrons behaved like particles. They stopped behaving like waves. They were only particles. Now, this is very confusing. It was as if the particles knew somebody is watching me, so now I should behave properly. Like the child, when the parents are not watching, it's very naughty. But when somebody is watching, it behaves properly, So the particles also was behaving like this. Somebody is watching me, so let me behave like a particle. Now there was confusion. Is there a problem with the detector? Was detector doing something? It may not be because we are watching it. The detector is interfering with the experiment. So they tried many different options. When they removed the detector, again, it was waves. So when they put back, so what it looked like, the conclusion you can draw from this experiment is when nobody is watching, a particle does not exist. Some vague thing called a wave exists. And only when you're watching, only when somebody is watching, the particles make an appearance. And whatever they did, they could not cheat the particles. They tried many different methods to see if somehow they are able to observe the particles. But whatever they did, whenever the particles knew an observation is going to be made, they behaved like particles. And when there was nobody to observe it, then they behaved like waves. This is a very interesting variation of the experiment, which I want to tell you. This is a very simplistic version of that varied experiment. So there was a question on whether human observers are causing those particles to behave like this, or just the detectors causing the particles to behave like this. So what they did is, in one version of the double slit experiment, they scrambled the information coming from the detector so that no human being could read the information in the detector. Now, what do you think happened? That particles seem to realize that nobody will be able to see them, even though the detector is there, and they behave like waves. Really, it is as if the particles knew. They have some kind of omniscience to know when somebody is going to watch them. So even when they did a variation where they don't even put a detector here, they found a way where in the future, after the experiment is completed, they can retrace the path of the particle. So even then, particles seem to know that in the future, somebody will observe them and they behave like particles. And only when there was no possibility of observing them, they behaved like waves. So you can imagine how it's almost like, it is like some sort of magic is happening. Like I am watching it, then it behaves like particle. When I'm not watching, it behaves like waves. So it led, based on this experiment, the founders of quantum physics, people who formulated quantum physics, like Niels Bohr and Werner Heisenberg, they concluded that a particle does not have any real existence until it is observed. Only when an observation is made, a particle exists. This is called the Copenhagen interpretation. Before you make a measurement, a particle does not really exist in a definite place or has a definite actual motion. So nothing, it does not exist. And so the whole universe is made up of particles. Nothing is real unless it is observed. This was the conclusion arrived at by the founders of quantum physics. And can you see how close it is getting to Vedanta at this point? Can you see the Sakshi Chaitanyam emerging from the laws of physics? But this was so against everything that we know and that we experience that it was many people could not, even the greatest minds of our greatest scientists could not wrap their heads around it. One of the strongest opponents of quantum theory was Einstein. He said there must be something incomplete or wrong about the theory. This defies all logic. Whatever you're saying defies all logic. He famously remarked, do you mean to say that moon does not exist when nobody is watching? How can it make sense? So there was one school of thought, one set of scientists who said that maybe there is something which we are missing. Maybe there is some hidden property of matter which we are missing. So we are not able to understand it and we are assuming that something strange is happening. So an analogy would be like you're watching a magician perform on the stage. So he's doing a lot of magic tricks and it looks fascinating to you. But why does it look like magic to you? Because you don't know really what he's doing behind the scenes. If he were to call you up on stage and explain to you how the trick works, it will make a perfect sense for you. It will make perfect sense to you, right? So that's how the universe is. That's what the scientists were, one set of scientists were thinking, those who are opposed to quantum physics. If when we really understand this hidden information, it's called the hidden variable theory. If we understand this hidden information, this whole quantum physics will make sense. In its current form, it is incomplete. So what it says, its inferences it's not accurate. So that was one school of thought. And there was another school of thought also made up of very great minds, starting with Niels Bohr to Richard Feynman, who all said, no, quantum physics is absolutely correct. And this is how the universe works. And for a long time, there was no way to experimentally prove which is the right explanation. So how do you find out an information which you're missing, but you don't know what you're looking for? So it is a very hard problem to solve. And how do you say something is that we have not missed anything? That is also a hard thing to prove experimentally. So that's when this year's Nobel Prize for Physics, those physicists, that's what they did. They created an experiment and proved that quantum physics is right. There is no hidden information. Quantum physics, whatever quantum physics says, that particles don't exist unless they are observed, is absolutely right. And they were able to experimentally prove it. And that's how they were awarded the Nobel Prize for Physics, because this problem has been confusing the mind of greatest scientists for such a long time. So in effect, what they actually proved is that the world is not real. In physics, there is a specific definition of what is real, what is reality. So when we say something is real, it has to have two properties. First is called locality. Locality means it can change only if something touches it. So if I have to move my phone from one place to another, I cannot move it magically. I have to touch it, apply force, and move it. It's based on Newton's law of motion. Everything will continue in its state of rest or uniform motion until it's acted upon by an external force. So if I'm in this universe and hundreds of light years away, something is happening, that event cannot affect me here because it has to take 100 light years for anything to travel to this part of the universe, right? But the universe does not follow this locality. Things which are billions of light years apart can affect each other almost instantaneously. So it defies the principle of locality. One property that anything which is real should have. And the second property is called realism. Realism means things should exist outside your mind. There should be objective existence for things. Now I'm looking at this screen. And after some time, I'm going to sleep and say in my dream, the same screen appears. I can say that my dream screen is not real and this one is real because it has an objective existence. That's our That's our normal day-to-day experience. But what quantum physics says and what the scientists have proven is that's not true. Nothing really exists until it is observed. So they proved that the universe is not real. Think about it for a second. Think about it for a second. Thousands of years ago, our rishis made this statement. Universe is nothing but Maya. It's just an illusion. Maya, Kalpita, Desha, Kala, Kalana. This whole universe, this time and space is just Maya. It's just an illusion. And and hundreds of years of scientific research as we went deeper and deeper into the mysteries of nature, to the mysteries of the universe. And at the deepest level, when we uncover the laws of nature, we find that what our rishis said is absolutely what the science is also saying. And how amazing is that? It just blew my mind just to think about it. So let us do, I think we are coming close to the 1 hour time frame. So I'm not going to go any further. But I just want to say that if you're looking at this Nobel Prize of Physics, and if you think, okay, there is the depth of coherence of this finding to Vedanta, it is really deep. At one stage, you can actually correlate how Tattvamasi, the Mahavakyam, I am Brahman, correlates with the observer effect of quantum physics. I have done this analysis and posted it as a video in my channel. I will just give you the title of the video so that you can watch it, because that will take me some time to explain that concept. How Tattvamasi correlates perfectly with the observer effect of quantum physics. So do visit my channel and watch this video titled Nobel Prize for Physics 2022, Universe is Not Real. Okay, with that, I'll end my session and I'll take any questions. Thank you.
Om Shri Guru Pyo Namaha. Thank you so much, Srimati Archana ji.
Thank you.
It was very enlightening speech, bringing the parallels of science and Vedanta. And thank you so much. I know your years of research, your depth of understanding of the subject, particularly the quantum physics and Vedanta, and your ability to present it in the subject in such easy way with a lot of examples and analogies makes it very, very easy to understand. And it makes it a very memorable talk, to which I'm sure our audience and the many who would watch it later on YouTube will have a lot to take away and ponder about. Thank you so much. Your speech makes it very clear to me that there are no atheists in the world. It's only ignorant people. Anyway, please accept our appreciation for taking the time today to talk to us. It was, as I said, very memorable. Thank you so much. Let me check if I have any questions from our audience. But you explained it so well, I'm sure there may not be many questions, but you never know.
Just one question. Archana ji, being exposed to both physics and Vedanta and also temples, how is your own perception of your life?
Oh, how it has affected my life, you mean?
Yeah.
Actually, yeah. So actually, there are many aspects to this question, Doctor. First of all, from childhood, both my parents are deeply religious people. My mother introduced me to, she's a philosophical aspect, Vedanta and Gita. She introduced me to those things. She only introduced me to my guru also. And my father is a great lover of temples. So we used to go visit temples often. And I used to hear about stories of temples from him. So I developed the love for both these subjects from childhood. And then, in my childhood, I watched this series called Cosmos, Carl Sagan's Cosmos. And I fell in love with physics. So all my life, these three subjects have been, have shaped my life and have been so much a part of me. I'm very passionate about all these three subjects. And throughout, I never found any contradictions. Always people will say, if you're a person of science, you can't be a person of faith. For me, I always felt that I could see God more clearly in science. When I was a child, I remember, in one of my physics class, I think my teacher was explaining the property of water. How water, it is densest at 4 degrees centigrade, and it freezes at 0 degrees centigrade. That's why ice floats on the surface of water. Like all other substances, when it's solid, it sinks down. No, the liquid form will be lighter and the solid form will be heavier. So it will sink down. But only in ice, the solid form is lighter than the liquid form. That is why it floats on the top. And because of this property of water, all life forms are preserved under oceans and rivers during winter. The water on the top freezes, but fishes and other life forms are able to stay alive. So when I heard this, I just felt this is goddess, this is Lalita Parameshwari. Lalita Sahasranamam, I chant every day. I learned it in my childhood. And I feel this is mother, So I've always found only God in science, I feel.
Thank you.
I have one question. This is Kishore.
And tell me, Kishore
why do some temples attract very large number of people, whereas other temples hardly have any devotees?
Yeah, there is many different explanations for it. If you look at a Laukika explanation, a materialistic explanation, some temples were, protected by rajas and celebrated by kings, got lot of wealth, and many sages have sung about these temples. So they have gained popularity. But if you see, according to Agamas, certain ways in which you invoke the god, it attracts certain types of devotees. Tirupati and all, they say Dhanakarshana Yantra is there in the feet of God, was invoked when it was established. That is why it is the wealthiest temple in the world. It attracts so much wealth. So there is both a spiritual and a materialistic explanation on why certain temples are more attractive.
Can physics add anything to that?
Physics add in. I think our temples are marvels of engineering and, science. You find so much, the way our temples, if you see that big temple, Brihadishwara temple and all, what a marvel of engineering it is. Near my, on the way to Tirupati, there is this beautiful temple called Vedanarayana Swami temple. And 3 days in March, the rays of sun will fall at 3 points on the idol. And the idol is so inside, the sun's rays have to travel through Gopuram and come and touch the idol at these exact points. And they've designed it and placed it so beautifully that when the Uttarayanam starts almost near the summer solstice, on those 3 days, the sun's rays fall on the temple. So every temple, I think, is a marvel of engineering and science. Without scientific knowledge, as Sulabha Sutras and all, Pythagoras theorem is there in Sulabha Sutras, and they developed because they wanted to build altars for Vedic rituals. So Vedas means knowledge, and science was integrated in all our rituals and temples.
Thank
I
you.
do have a couple of questions from the audience. How would the probability of the consciousness behind the creation of the universe change if it was actually a multiverse?
See, what is the thing with multiverse is, let's say if you have infinite number of universes, I told you for a deck of cards, every possible combination of deck of cards is a very large number. It's a 68-digit number. So large it is. So if you have that many number of universes, let us assume. So the probability that one universe has a low entropy beginning, one universe has perfect values for creation of life is there. So if you have infinite number of universes, right, infinity encompasses everything, right? So every possibility exists in an infinite universe. That's why the probability is there that we are living in a universe out of the million, trillion universes that are there. We are living in one where life is possible. But the challenge with multiverse is everything which science criticizes about God, the same criticism applies to multiverse also. There is no way to prove it. You cannot observe it. You cannot touch it. You cannot, it is impossible to reach it. But you have to just assume that it exists, because you don't want to assume that God is there, that there is intelligence behind creation. As far as science goes, if you say there is God, there is intelligence, then you have moved to the dark side. So you'll have to find another explanation, which will, however improbable it is, and another explanation which does not include God. So that is why so far, that is the reason why multiverse has been said. Because this probability is so impossible, and it can happen only if we have infinite number of universes, and we are in one out of that infinite universe.
The next question, science strives to explain everything by mathematics and experimentation. On the other hand, Vedanta says we can achieve this through self-realization. Do you think science will hit a roadblock?
See, actually, Raviji, when I learned Vedanta, one of the first things I learned from my guru is consciousness can never be proven by science, because science is all about objective experience, what you can see with your senses. And one of the definition of Brahman, of consciousness, is asparsham, arupam. So it has anything which is an object of your sense can never be proven or experienced or seen. So science can never come to consciousness. But now the current state of science has disproven that we are able to actually see and experience consciousness through science. So whether the spiritual aspect of finding the universe within you, whether the Vedanta can, the path laid down by our rishis can help us, aid us in the discovery of the laws of universe, I don't know. Because Vedanta also doesn't say that you can understand the laws of universe by looking within yourself. You can understand that you're Brahman by looking within yourself. So that is one thing which you can do. Aham Brahmasmi is something you can discover. Yes. But whether the laws of the universe you can discover by looking within yourself, I'm not sure about that.
What evidence do people who oppose the idea of a consciousness purpose behind the creation of the universe use to prove their stance?
That's what. One of the things which they say is it's a multiverse. There are millions of universes, and we are in one of them. Even the observer effect of quantum physics, before these Nobel Prize winning physicists proved it, there was an argument that we are missing something, and that is why we are feeling that our observation is making this difference. Just before this Nobel Prize for physics was announced, there were two camps. One camp which said this is not how the universe behaves. Everything exists. It's just that we have not understood it properly. If we understand quantum physics well, it will make perfect sense. But now the current Nobel Prize has disproven that. So we have to see what science has to say. What is the next inference the science is going to draw from that conclusion?
There's probably one last question. Why did Big Bang occur?
Yeah, even science does not have an explanation for it, but our Vedanta and our Shastras have an explanation. Every universe occurs because there is, I showed you that that picture of Vishnu sleeping and dreaming up the universe. And Ranganatha. What is the bed which Ranganatha is using? He's using Adishesha, a serpent with countless heads apparently. And those countless heads are supposed to be our leftover karmas of all beings. That's why it's called Shesha. Shesha means what remains. The leftover karmas of all beings causes the next universe to occur. So what causes the next universe according to our Shastras is all our karmas. But science does not have an answer to why the Big Bang occurred.
Thank you so much, Archanaji. You explained very well all the questions. Before I hand over to our chairman, one of our volunteers, Sri Bhaskaran Rajamani, want to say something to you.
Sure.
Namaskaram. Can you put Bhaskaran on the line?
Namaskaram, Archanaji. Thank you so much for your fantastic explanation. We are very, very excited about this for so many reasons. I'm going to remove my blur so I can get my normal view. So we are actually also disciples of Swami Paramatmananda. We've been listening for the past 15 years. So all the shits and everything. And so we're so happy to see you. And I have listened to his lecture on science and Vedanta, and where he says, science cannot come explain Vedanta. But now I'm hoping that he's going to give us a new lecture with your, the quantum physics, the Nobel Prize, and everything that has recently happened. And my excitement about this is, this is going to open up a whole bunch of youngsters who are really very scientifically minded, who are constantly questioning everything that we do in our religion, and all the Sanatana Dharma and the Vedantic thoughts will all start thinking about it. Will start pondering about this and say, hey, this is something that I cannot ignore. I need to really do more about, and I need to understand. I need to deep dive into it, and so on and so forth. So thanks for initiating that spark that is going to really light a whole bunch of brains and minds to start thinking about it. And sincere thanks to you for being part of a SVBF.
Thank you so much.
Evening.
Thank you so much.
Can I request our chairman, Dr. Lakshmanan, to please talk?
Namaskaram, Archana ji. Thank you very much for giving us this wonderful lecture. We're all very privileged. And this subject of science and spirituality is very, very timely. And for us all to know, particularly we from SVBF, being able to bring in a speaker like yourself and help us understand and take us to another level. I really want to thank you on behalf of SVBF volunteers and the board. Thank you very much. I just want to make a mention, Archana ji, that is when President Kalam wrote his book, Vision 2020, with the directive from late Prime Minister Vajpayee, with the help of various scientists, academics, and the bureaucrats. He brought various enablers to make India prosperous by 2020. But he felt something was missing. So he went to Guruji and asked him, how can I take it to the people and make sure that India realizes the prosperity by 2020, whatever his roadmap was, education, healthcare, and all that. The Guruji told him, find people who have faith in God, and they can be the leaders taking your message, and the whole India and everybody will be prosperous and peaceful. This clearly narrates what you've been saying, that there is so much in spirituality and so much, we all have to have faith, and that helps us to have a peaceful life. Archana ji, we have to bring you more often so that you can narrate your experience being a good physicist, your experience with the science as well as the faith in God, and for our devotees and people to realize. I request on behalf of SVBF, probably will arrange more lectures from you so that we can all be more knowledgeable in what we've been doing. Thank you very much, Archana ji. I want to thank our volunteers, Parambat, Ganeshan, Ravi, and Alakananda, and Kishore for all your help. Let us continue with the journey and arrange more such lectures for devotees to benefit. Thank you very much. Thank you very much, everyone.
Archana ji, before you go, for your information, our chairman, Dr. Lakshmanan, is the recipient of the highest civilian award in Canada, the Order of Canada, as well as he is one of the recent recipients of the Bharatiya Pravasi Award from the President of India. He just returned from Indore after receiving the award.
Honored to meet you, sir.
Thank you so much. We will conclude the session with this.
Thank you.
Thank you.